Yo, Math Topic students, it's Mr. Donaldson, and this is Unit 3, Statistics, and this Section 1 is just an intro to some basic concepts of statistics and some terminology we use throughout the unit. So the first term is a population. A population includes all items of interest in a statistical study. So like for instance, if I wanted to do some statistical analysis on all the GPAs of students at Boulder High School, every single student's GPA at Boulder High will be the population. Everybody, every number that's involved, every GPA that's involved. And then the next thing is a subset of population is the sample. And a sample includes some, but ordinarily not all, of the items in a population. So maybe I wanted to figure out, hey, what's the average GPA at Boulder High School? And it was just too hard for me to ask every student. So maybe I just randomly select a sample of that population, and I can calculate the average or whatever I wanted to find out with the sample, and it might give me a good idea as to what the population would look like. The next thing is descriptive statistics. Is when you collect data, organize data, summarize, and present it. We call this descriptive statistics, or stats, to save you some writing. All right, so yeah, it just kind of gives you an overall representation of like, what does this data look like, you know? The next thing is inferential statistics. This is when you use the data to make an inference or to draw some sort of conclusion about the populations based on the sample information. And you guys remember, I'm not going to ask you to give me definitions word for word, but these words may come up, these terms may come up, and I just want you to understand what we're talking about. So yeah, if I just like went and collected a random sample of students at Boulder High, and I was like, oh, the average GPA of this random sample of 100 students is 3.7, then I maybe would say, oh, okay, well, based on this random sample, maybe the population of the school would have about an average 3.7 GPA. So just drawing a conclusion about the population based on what I found in a sample. All right. Information that has been collected but not yet organized or processed, we call that raw data. That's when I just walk around, I'm like, hey, what's your GPA? What's your GPA? What's your GPA? I'm just writing all that down. Haven't really organized it or really processed it yet. That's just the raw data. All right, and then there's two types of data that we'll talk about. There's qualitative data, or excuse me, quantitative first, which is numerical, like quantities. Quantitative. Again, my handwriting is terrible, sorry. And then there's qualitative data, which is non-numerical. So for instance, quantitative data will be like the GPA example. What's your GPA? And I got everyone's GPA. It's a number, right? It's that easy. Qualitative data will be like, hey, who are you voting for president? Some data that's not a number. So how this all kind of fits together. To predict the outcome of a presidential election, we wanted to really make a true prediction, then we would have to poll the entire population of voters. But, that's not feasible to ask every single voter in the country, who are you going to vote for? So rather what happens is we poll a random sample of voters, and then we make inferences about who most of the entire population is voting for. In this type of statistical inquiry, the data are qualitative because we're not asking numbers, we're asking, hey, who are you going to vote for? Okay? So, yeah, that's that. Let's go to the next page. Okay, so these are called measures of central tendency. And if you guys want to pause the video and write these down, you can, but I'll just kind of talk you through them. The following are terms that describe quantitative data, so numbers, all right? They give you information about how the data is centralized and spread out, all right? Before finding these measures, we organize the data sequentially, and it makes finding the values easier. So first, the mean. The mean is just the average of the data, right? Remember, this is all quantitative, so numbers. So to find the average, you just add up all the data values. And then divide by the number of data values. You guys know how to find an average. And we'll do some examples on the next page. All right, the median, or Q2 is how it's referred. That's like a little abbreviation or a shortcut for median. And it's the number in the middle of the data when the data is written sequentially. That's really important. If I ask you to find the median, make sure it's written from smallest to biggest first. All right, if there's an even number of data, then the median is the average of the two numbers in the middle. And I'll show you an example in a minute. The mode of the data is the value or values that appear or appears most frequently in a data set. All right, a set of data can have more than one mode. All right, so for instance, if I had like 1, 2, 3, 3, 4, 4, 5. If I'm looking at this data, you'll notice that there are 2 3s, and you'll notice that there are 2 4s. So 3 and 4 occurs more than the other pieces of data because there's only 1 1 and 1 2 and 1 5, but there's 2 3s and 2 4s. This data set would have 2 modes. The modes would be 3 and 4. The range of the values, or the range of the data, is the difference between the greatest value and the least value. So back to this example, the way you'd find it is simply difference in math is subtraction. So you would just do 5 minus 1. So the range of the data would be 4. All right. The first quartile is the median of the first half of the data. And when I say first half of the data, I mean the data values that are below the median, below Q2. And in Q3, the median of the second half of the data. And when I say second half of the data, it's the data values above the median or above Q2. And in just a minute, we'll do some examples, and that'll make more sense to you once we do it. And the last 2 things here are maximum. This is pretty obvious. It's just the biggest value, and minimum is the smallest value. All right, so here are some examples. All right, and I have all of this data already in sequential order for you. You're welcome. All right, so the data value, or the data below, are grades from a random sample of math topic students. Okay, so just randomly pulled some grades of students. All right, I put them in sequential order for you. All right, and these numbers are made up. No one has an 8 in the class right now. So if I want to find the mean, remember mean is the average. I'm going to add all these numbers up, and I'm going to divide by the number of values there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So I'm going to divide by 11, and I'm just going to add up all the numbers. So I'm going to punch this in my calculator. All right, 8 plus 33 plus 58 plus 63 plus 74 plus 82 plus 94 plus 94 plus 95 plus 97 plus 99. So it's a bit tedious, right? We add up all the values. I get 797. Divided by the number of values, which was 11. So the mean, or the average of this data, is around 72.45. All right, next is the median. Now remember, the median is a number in the middle. So I know that there are 11 values here. Oops, I shouldn't have done my work there. My work for average should have been right here. 797 divided by 11. So I know there are 11 values. So that means there's going to be 5 numbers. This would kind of represent the first half of the data. Then there's the median, the number in the middle. And then there's 5 numbers past it, which will represent my second half of the data. Okay, so the median is the number right in the middle, and the number right in the middle is 82. That's the median of the data. The mode is the value that occurs most frequently. So I'm going to see if any number occurs more than once here. Let's see. Looks like 94 occurs more than once. It occurs twice. So 94 would be my mode, the number that occurs most frequently. The range is found by subtracting the smallest data value from the biggest. So 99 minus 8 equals 91. Q1 is the median of the first half of the data. So check this out. If this, and remember, when I say first half of the data, I'm not including the median. The number's below the median. All right? So if I want to find Q1, it's the median of just this first half of data, or the middle number of this first half of data. I'll put a little triangle around it so I can show you. Q1 would be 58, because there are 5 values here in the first half of data, and 58 is right in the middle of it. Q3 is the median of the second half of the data. So I look, the numbers above Q2 are the numbers above the median. And if I find the middle of that, we'll do maybe a circle around Q3. It will be right there, 95. And then the median, we did a square around. So you can kind of see that in the data values. All right, the maximum, of course, the biggest number, which is 99. And the minimum is the smallest number, which is 8. There you go. Pretty straightforward, right? You guys probably heard most of these words before. I'd say maybe Q1, Q3, and median, something you're not super familiar with, but the rest should be pretty familiar. All right, so a couple years ago I asked, this was legitimate data, I asked students how much money they were making an hour a couple years back, and this is the values the kids gave me. I polled 8 students in my class, this random sample, right? It wasn't the entire population. My class had more than 8 students. This was a sample of the class, right? And so I'm just going to calculate the mean, the median, and the mode. So the mean, I'm going to add up all these numbers, and I'm going to divide by 8 because there are 8 numbers. So when I do that, when I add them all up and divide by 8, I get that the average or the mean is approximately $12.18. So I just added up all these 8 values and divided by 8. All right, so the average salary or hourly rate of those students was $12.18. Now the median is the number right in the middle, but check this out. This is an even number of data, right? There's the first 4 and there's the second 4. And as I told you on the front side of this paper, when there's an even number of data, the way you find the median is you average the numbers in the middle. So I'm going to average 11 and 12. So I'm going to add, 10 and 12. I'm going to add 10 and 12 together. I'm going to divide by 2, and that gives me 11. So the median is 11, right? Here, the median is 11. The mode is the number that occurs most frequently, right? And so the mode occurs most frequently, and that data value was, let's see, $9.30 happened twice, and $12 happened twice. So there's going to be 2 of them. There's 2 modes, the $9.30 and the $12. Right, 2 12s, yep, and 2 $9.30. Perfect. Now you guys, I know it doesn't ask this, but this is a good example when you find Q1 and Q3 when you have an even number of data. Remember, when I'm finding Q1, it's the median of the first half, and that's the numbers below the median. Well, the median was 11, so all this is the first half of data. So if I wanted to find Q1, it's the average of these 2 numbers in the middle. And so $9.30 plus $9.85 divided by 2 is about 9.575, or about, if in money, about $9.58. And if I wanted to find Q3, which I know doesn't ask me, but this is worth pointing out, I'm going to take the second half of the data, which is these 4 numbers, and the number right in the middle there. But the number right in the middle, there isn't a number in the middle because it's an even number. So I'm going to average 12 and 15. And when I average 12 and 15, what do we get, like $13.50, right? Punch it in. Yep, $13.50. So Q3 will be approximately $13.50. Yeah. Okay, last couple examples. Okay, sorry, I kind of glitched out there on me. So here we are, you guys, for these last, this next example, example 3. Remember the first thing I said you got to do is you got to put the data in sequential order. So we're going to start with the smallest data value, which is 3. Then the next smallest is 12. Then 14. Then 18. And then 18. So make sure you do that first. All right, so the mean. The mean is just the average. I'm going to add all these numbers up, and I'll divide by 5. And when I get 13 is the average, or the mean. And this symbol, you guys, an X with a bar on top, is a symbol for mean. All right, the median. The median is the value in the middle, which of course is 14. And then the mode is the value that occurs more than the others, and that will be 18. 18 occurs twice, and the other values only occur once. All right, the next question says, okay, suppose you add the numbers 3 and 23 to this data set. Which values will change? All right, so which statistics or values will change? So first of all, when I calculate the average again, so I'm going to add up all these numbers, including the new 3 and the new 23, the average or the mean is still 13. So the mean does not change. All right, next, the median. The median is still 14 because it's still the number in the middle. I add a number in the beginning and a number at the end, so 14 is still the median. But what changes is the mode. The mode of the original data set was 18. But now this is bimodal, or has more than one mode. It has 2 modes. The mode is 3 and 18. So what would change would be the mode, nothing else. All right, and then these last examples, you guys, I probably only have time for one. It cuts me off at 15 minutes. So I'll do the second one in class with you. Create lists of numbers that have the given characteristics. So the first thing I know, let's see, the median is 8. There's an even number of data, so the average in the middle terms is going to be 8. I know the maximum is 20. That's easy enough. The range is 15, so when I do the biggest minus the smallest, I got to get 15, which makes the smallest value 5. The mode is 5, which means 5 has to occur more than the other one, so I can go ahead and put another 5 here. And then to figure this out, I know that these 2 middle terms need to average to 8. Well, 5 is 3 below 8, and 11 is 3 above it. So bam and bam. There we go. Those data values have all of these descriptive statistics. I'm out of time. We'll finish